Hello everyone, this is an API Gateway overview video where we're going to learn about the key concepts, the key features that API Gateway provides, and also run through some practical examples so you understand exactly how API Gateway works. So the first thing I want to do is just talk about some key ideas or key concepts that you need to be aware of when you're learning about API Gateway. And the first is, well, what is API Gateway? And the answer is that it's a managed service for HTTP, REST, and WebSocket endpoints. So it allows you to build these endpoints that you can expose to your clients so that they can interact with resources or services that you build within your AWS account. And there's three different flavors here, HTTP, REST, and WebSockets, that are useful in different contexts. So HTTP and REST kind of go together, and these type of endpoints are suitable for request response models where you have a client that's trying to make a request to a server, that server receives that request and wants to respond with some data. So stateless applications generally. Whereas WebSocket endpoints are more for supporting bidirectional messages and broadcasting, things like chat applications or real-time gaming applications, where you want to send data directly to the server and have a stateful connection where it's returned back to the client. Also where you want to do like broadcasting to multiple different connected clients all at once. That's great for WebSockets. Now, the confusing part, and this is kind of where I got lost for a long time when working with API Gateway, is the fact that the supported features are very different depending on if you're talking about HTTP, REST, or WebSockets. There are some similarities, but for the most part, you're going to have a very different time when you're working with each of these. And this is something that I hope I can make a little bit more easy for you to grapple with when you're working with API Gateway as well. So first, let's just talk about the three different variations here, HTTP, REST, and WebSockets, to understand a little bit more about how they're different in the context of API Gateway. So like I said, HTTP and REST are very similar, but there is kind of a slight difference between them. So for HTTP, it's kind of like a basic feature set that allows you to build very low latency and cost-effective REST APIs. Very simple, very bare bones. You don't get a lot of the bells and whistles that you would get in the other flavor, which is the REST flavor. And REST is, like you would kind of imagine, it's an enhanced feature set that allows extra functionality at the penalty of higher cost and higher latency. So what kind of extra functionality are we talking about here? Well, things like custom authorizers that integrate with AWS Cognito, things like web application firewalls, things like API keys that you can give to your clients so you can have specific clients that have usage plans. These types of features are supported in REST, but not in HTTP. So if you're finding yourself in a situation where you're trying to decide between REST and HTTP, well, the test should be, do you want to use all these extra features, all these bells and whistles that come with it? If that's the case, then go with REST. But if you want just a very bare bones API that's going to get the job done and you don't care about all these bells and whistles, then go with HTTP. So these two, you kind of need to do some thought when you're comparing when to go with one or the other. And for WebSockets, WebSockets are just for a completely different use case, right? They're for bidirectional communication between client and server. And so there's no real comparison that you need to do when you're deciding to use WebSockets or not. It's completely use case driven, so not much to grapple with there. So now I want to explain through kind of a hands-on practical example on how a user would interact with HTTP and REST endpoints, and then we're going to do the same kind of exercise for WebSockets. So let's start with HTTP and REST. And so the main idea when you're thinking about API Gateway in general, just a way to conceptualize it or rationalize what it represents in the context of AWS, think of it like a front door to all the different resources that you may store in your AWS account. This can be things like databases, things like event orchestration systems, things like private resources, all sorts of stuff that you can have in your AWS account. And you want to expose all of that information to the outside world, either through some other client or through the public internet. And so that's the main feature, the main functionality that API Gateway helps you deliver. So it helps you build APIs that different users can interact with. So let's take an example now talking about maybe the public internet where there's different clients that want to connect to your API Gateway endpoint. So these clients can be, well, many different types. You can have cell phone users using maybe a mobile application or a website on their application. You can have a web app connected to from a home machine. You can also have other client machines or other services that are hosted on servers themselves that are trying to interact with your APIs. They would all be connecting running through the public internet. And when they connect to your API, they may connect through a particular resource. So in the world of REST, you typically work with resources. In this case, it could be customers, and usually you have a verb associated with it. So there could be like a GET request, a PUT request, a POST, a delete, many different types of requests or methods that you can associate with these different APIs. And this is indeed supported with API Gateway. And so what does API Gateway do when someone tries to connect using this particular resource? Well, there's a bunch of different options, and all of this is configurable depending on how you want to use API Gateway. So one option is, say you have some resources that are directly in your AWS account that you would like to expose, or some kind of functionality. So what you can do with your API Gateway is connect it directly to those resources. Say, for example, a DynamoDB table or an Amazon EventBridge event bus. You can let your client essentially push data into your DynamoDB table or retrieve data using what's called a service proxy. And the service proxy is just the idea that API Gateway will essentially forward the request that hits your customer's endpoint, and it'll directly interact with whatever service that you configure, DynamoDB and EventBridge in this case. Now, this is not the conventional way to interact with API Gateway and your backend resources. The more common way is to use a service like AWS Lambda. And instead of using that service proxy feature, instead your API Gateway is connected to your Lambda function. And then within your Lambda function, you implement some business logic that chooses to decide what resources am I going to interact with before returning all of that data back to the caller. So that's the general idea of API Gateway. You have clients that are connecting to endpoints that you create. You can connect them either directly to some AWS services, but the more common connection point is with a Lambda function where you can implement your business logic. Now, similarly, within this same Lambda, you also have some different options. You can choose to call other API Gateway endpoints that exist within other AWS accounts. And within that other AWS account, the same concepts apply. They can have a Lambda function or other AWS resources that they are connected to. Now, in this case, this type of API is not exposed to the public internet. This is what is considered to be a private API. This is also a feature that's supported in API Gateway as well, where if you don't want to expose your API with a public-facing URL that people can potentially call, and you want it to be private and exist just within a VPC that you give another AWS user's account access to, then you can build this private API to keep all of this stuff hidden and not expose your endpoint to the outside world. Now, in addition to these kind of basic features, there's much more comprehensive features that are supported as well. So the first is that the service is extremely scalable and elastic. So there's no servers that you need to manage here. It's a completely managed service. It'll scale up or down. It'll load balance all your requests that are hitting your endpoint and distribute them to the correct locations. So there's no maintenance or any kind of operational overhead when you're working with API Gateway, besides just being aware of some of the limits that apply, which I'll talk about a little bit later as well. In addition, there's also a caching layer as well. So if you have data that doesn't change very often, maybe data that kind of you set it once and it stays like that for maybe permanently or maybe a shorter period of time, you can set up caching so that instead of hitting your Lambda function or calling your database again, you can just return that same data set back without having to go to the home location. And you can also set a TTL or time to live on this as well, so it'll expire after a period of time and then get refreshed once it does expire. It also supports rate limiting. So say you may want to say for this customer's endpoint, you only want to support maybe 100 requests per second. You can set up rate limits there. You can also set them up to be on the client level. So a particular user that has a particular API key, you only want them to call with a certain amount of requests per second, and even usage plans. So you can say they can only call 4,000 times a month. That's also configurable as well. In addition, there's also comprehensive monitoring through the form of metrics, dashboards, even logs on the request level. So when folks call your endpoints, you're able to see what exact parameters are passed into your endpoint and what exact response values are sent back to them. So you can enable all sorts of custom logging on this as well. You also have comprehensive security features too. So since we're exposing our APIs to the public internet, we don't necessarily want them to be kind of abused by different users that don't have permissions to call them. We can set up authorization on our API Gateway endpoints such that only logged in users, either through AWS Cognito or any other identity provider, will have the ability to interact with our API itself. So we can lock down that API that way. And finally, we also have access to different deployment environments. So we can set up different stages. So for example, like a beta stage or a test stage, and then a QA stage, and then a prod stage. And then we can make changes to our stages independently, test out a feature, make sure kind of throttling is enabled correctly if we decided to enable it before moving that to production and start affecting other users as well. So we can phase in these different things slowly through the use of different deployment environments. And so this is HTTP and REST. Now do keep in mind that some of the features that I just talked about are only supported for the REST variant and not supported for HTTP. But before we get into that more comprehensive comparison of the different feature sets of these two things, I want to briefly talk about WebSockets and do a similar kind of example to show you how that works with API Gateway. So let's do that before we get into the comparison. Okay, so moving over to WebSockets. So a lot of the things stay the same. What is a little bit different is that there's a little bit more work for you to do from a developer perspective to get this all set up and working. So when you create a WebSocket endpoint in API Gateway, you need to create different paths or different resources. So the first one is called the connection path, or it's /connect. And the way this works is that when someone connects to your WebSocket endpoint, it's going to trigger whatever integration that you specify. Now, the most common integration that people use is AWS Lambda. And what gets provided to your Lambda function whenever a user connects to your WebSocket endpoint is kind of a connection ID or a session ID for that particular user. So you're past that into your Lambda function. You can choose to save that so you hold on to it later. So if you'd like to broadcast messages back at a later point in time, you can reference that particular user using that connection ID. Now, in addition, you don't necessarily have to use Lambda here, but it is by far the most common because API Gateway is already serverless. Lambda is also serverless. These two things go really well together. But the interesting thing to think about is that when you're working with WebSockets, more traditionally, you have kind of hard metal machines or just VMs or virtual machines, and you typically form sticky sessions with them or sticky connections such that when a user connects to your endpoint, it gets directed towards a particular machine, and anytime they kind of send data or update state in any way, it goes to the exact same machine. That's not how it works with AWS Lambda. AWS Lambda is completely serverless, so when a user connects and when a user sends message content later, it may hit a different machine, but AWS Lambda handles all of that for you. You don't need to think about it at all, and that is by far the benefit of using Lambda as the integration type for WebSockets. And so similarly, there's also the disconnect endpoint, and you can also integrate this with a different Lambda function, or you can create a fat Lambda function that does all of these different things. I suggest doing it separately, but that's just a preference. So these two, connect and disconnect, are kind of like the initial overhead, things that you need to do in advance. By far the most interesting kind of endpoint that you'll create is when you want to actually send content to your backend. So I created one, a custom one here called send message. You can call this whatever you want. This is just what I named it. It's a particular resource that I created. And similarly, you can also associate this with another Lambda function. And so this is how you would send message from the client to the server if you want to send content in that direction. But what if you want to send messages in the opposite direction? You want to return a response back to the client, or maybe you want to broadcast messages to all the connected clients all at once. That type of behavior is also supported. So you can broadcast messages to the connected clients, either a subset of them or all of them, if you keep track of that connection ID that gets provided to you in the initial connection phase. And then when you remove that from your list that you're tracking in the disconnect phase as well. And so if you want to broadcast messages that way, you can also kind of integrate with another Lambda function, and you can submit a post request to a particular API Gateway provided endpoint with the connection IDs that you would like to broadcast the message to, and that will respond to the user and send that return content back to your connected clients. So just to recap how this works in general, you have users that connect to your API Gateway WebSocket endpoint, triggers a Lambda function, provides a connection ID. Typically, you'll save this in a database somewhere. If they go idle or they explicitly disconnect, the same thing happens, but you'll do that in reverse. When they want to send content to you, it's through a different path. You can trigger a Lambda function here and kind of respond to it in any way that you want. When you want to return data back to the user through like the broadcast flow, in that case, you would have your Lambda function function that reads off the different connections that you're storing in your database here to figure out, do I want to send it to a particular client or all clients or a subset of clients, and then submit a post request via API Gateway, and that will send that message all the way back to the client through the WebSocket endpoint. And so that's how WebSockets work with API Gateway. I do have a video of this where I walk you through this entire setup process. I'll put a link in the description section below. I'll also put a kind of a clickable thumbnail at the end of the video as well, where you can kind of watch that and get a tutorial. But that's how WebSockets work with API Gateway. Okay, so just one other small thing before we do that step-by-step comparison. I just want to talk about some key concepts that are common to REST, API Gateway, and WebSockets, things that you'll hear me repeat from time to time. And they are routes, sometimes also called resources, and stages. Now, routes are fairly self-explanatory. They're like what you see here. So routes is like a customers or /customers endpoint. You can also call them endpoint. In AWS documentation, they use routes or resources pretty interchangeably. I just call them endpoints. It's the most, I guess, easy way for me to think about it. And then within your different routes, resources, or endpoints, you have the different verbs associated with it. So there's post, delete, get, or put, depending on what you're trying to do. Obviously, this doesn't really apply if we're talking about WebSockets since they don't support this, but this only really applies for REST and HTTP. But routes/resources do exist. That was the send message route that I was speaking about in the previous slides. So they do exist for WebSockets. And then stages are a little bit different. They're the different kind of environments or setups. So in this case, I have 3 different stages. I have test, I have QA, and prod. And for each stage that you create, you get a different endpoint URL. So you can see this endpoint URL has /test at the end. That's the stage that we're talking about here. If you were to click the QA stage, you'd get /QA. And these are completely different. They're isolated from one another. And what this allows you to do is create some changes for your API, and then you can sequentially deploy them. So you can go to test first and then call this URL, make sure everything's good to go before sending it to QA and before sending it to prod as well. So you can do stage deployments in that way. And so these concepts apply regardless of if you're talking about HTTP, REST, or WebSocket. So I just wanted to call that out before we do the step-by-step comparison, which is our next item to talk about. Okay, so let's compare these 3 suckers, which is probably the most confusing part about working with this service. So let's compare this across 3 different types. So first, let's talk about throttling. And throttling is just the idea that you can limit the amount of usage on your API from the concurrency perspective. And you can also set up usage plans too, which I suppose is part of throttling. We'll talk about it here as well, but that's something slightly different. Anyways, in terms of the comparison between these 3, so for HTTP with throttling, you can set it up at the account and route level. For REST, it's set up at the account, route, stage, and client level. Client is like a particular client that has access to an API key that you can create and vend out to them. So if you're building like a SaaS app and you want to have different users that are going to be using your APIs, you can create different client keys for them and set up quotas so they can only call your API, 1,000 times a month, whatever you want it to be. And then for WebSockets, it's route, stage, and also it should be account as well. I think I missed that. So account is present for all of them. So that's it for throttling. And then we have usage limits, which I just kind of talked about. So it's not supported for HTTP and WebSockets. That is only supported for REST. Then you have DDoS protection. So that is not supported for HTTP and WebSockets. That is only supported with REST through Web Application Firewall, or WAF for short. And this does cost extra money. It's not given for free. This helps protect you from like bot attacks, from SQL injection, from malicious users that are spamming your endpoints. This will protect you and it's probably a good idea if you have any kind of public service or any kind of public application where you're expecting a production workload of traffic. Now, in terms of the other service integrations that you can interact with, so there's quite a few that are supported. For HTTP, it's kind of a limited subset. So you have around 10 or so. So some of those 10 are some of the more common ones like AWS Lambda, like SQS, like step functions. Those are included in that list. For REST and WebSockets, you have hundreds of different options to potentially integrate with, so you can check through that list. For caching, that is only supported for REST and it's on the request level, not supported for HTTP or WebSockets. For validation, you can set up validation such that when someone tries to pass a payload into your API, you can ensure that it has certain fields. The fields contain certain types, and those types are something that you expect. That's supported for all the different variants here. Similarly, for transformers, they can be used to remap fields to different names. So say someone passes in a field with a capital at the beginning and you want to kind of lowercase everything, you can remap it to a different name. So that's supported by all as well. And then for authorization, this one is a little bit prickly because it's different for each. So let's talk about each of them independently. So for HTTP and REST, they both support IAM. And IAM, you can do some pretty kooky things with this. So you can set up certain users with a certain account ID, certain VPCs. You can set up certain IPs as well. So lots of different things that you can do with IAM. They also support custom authorizers through the use of AWS Lambda functions. And when you're using Lambda functions for authorization, for your resource is actually called, so the thing that returns the data, there's a Lambda function that you can implement where where the request gets intercepted before it hits your actual endpoint, and it invokes your authorization Lambda function where you can validate the request, make sure it has something in its payload or something maybe in the header that says, okay, I recognize this user. Could be an API key. It's just a way for you to generically verify that this user has the ability to call your API. So that's done at the interception stage as part of the Lambda function authorizer. That's also supported for WebSockets as well. I called it custom here. I probably shouldn't have. I should have changed this to Lambda function. I don't know why I did this, but WebSockets supports this same process as well. What's a little bit different though with authorization for HTTP is that they don't support Cognito, like you can see here. They only support JWTs or JSON Web Tokens. And so if there's a particular attribute in your JWT, you can use that for authorization for your HTTP users. But if you're using AWS Cognito, which is another AWS service, an identity provider, you can very, very easily integrate your REST endpoint with it. So you can point it directly to a user pool and make it so that if a person has an account in your user pool, then they're allowed to call the endpoint. And it's very, very simple to set up. I do have a video on this as well, which I'll link to you in addition. And going to the last couple here. So in terms of monitoring, so HTTP supports only access logs, which are basic, just kind of metadata about your requests. Same for WebSockets, whereas REST gives you additional context. So they give you execution logs, which gives you all the details about your API. And you also have access to X-ray, which is kind of more granular scoping for your API invocations to see exactly where time is being spent calling your different dependencies. And finally, in terms of privacy, so for privacy, you're allowed to set up VPC connectivity for both HTTP and WebSockets, but REST APIs are the only ones that support private APIs. So if you'd like to create an API that is only accessible from a private VPC in AWS and not kind of observable through the public internet, you would have to use the REST API variant. So that's something to keep in mind as well. All right, so that's it for the comparison of features between the three. I want to talk about pricing now to give you just a preview of how pricing is set up for these three different services, or sub-services, I should say, just so that you know what you're getting into. And the good news is that they have a very generous free tier for you to experiment with. But one thing to keep in mind outside of the free tier and just in general is that there's one trap that people fall into, and they don't think about this when they're doing pricing or cost calculations with API Gateway, and it has to do with data transfer cost. And so you have to pay 9 cents per GB of data transfer out from AWS to the public internet. So if someone calls your API and you grab, a megabyte worth of data, for example, and then return that back to the user through your API, you have to pay money there. It's not for free. And so, 1 megabyte isn't a lot. It's 1/1000th of a gigabyte. But if you do this for many, many thousands of requests, this can easily stack up. So be careful with this. Make sure that you're accounting for it when you're doing your cost estimations. But it's something that I wanted to point point out because we're talking about APIs here. We're moving around data, typically to and from the public internet. So something you need to think about in advance. So in terms of the cost of the particular variants, they are different depending on if you're talking about HTTP, REST, or WebSockets. The good thing to know about is that there's a generous free tier. And for HTTP, you get access to 1 million API calls, but they are metered in 512 kilobyte increments. So that means if you have a request that is, 1024 kilobytes or 1 megabyte, that's going to count as 2 requests. For REST, it's slightly different. It's just at the API call level. Doesn't matter what the size is. It's just one API call is the same regardless of the payload. For WebSockets, it works slightly different. It's on the message level and the connections minutes level. And so you can send 1 million messages to and from via WebSockets, and you also get 750,000 connection minutes for free as well. Keep in mind, this is part of the free tier, which is only available for the first 12 months when you create your account. So if you created your account a long time ago, you may not be eligible for the free tier anymore. You can always just create a brand new account to test this out if you'd like, but just something to be aware of before you go and experiment with it. Now, once you go beyond the free tier in terms of the cost, for HTTP, it's about $1 for every 300 million API calls, which is a very, very generous and fair price, in my opinion. It is a bit of a gradient, so the more that you spend, it's slightly less, but it's not really even worth considering here. It's around 10% or so of a discount when you spend more. For REST, it is heavily kind of blended across the different usage profiles. And I just kind of grabbed the screenshot from the AWS documentation because it's easier. So for the first 333 million, it costs $3.50 per million. The next 667, it's 280. And then, the next 19 billion, wow, that's a large number, 238. Over 20 billion is 151. So it's reduced by over 50% when you're over 20 billion versus the first 333 million. These are insane numbers. Probably 99.9% of us are never going to even see these numbers, so it probably doesn't matter. So these are just the cost setups for these different usage levels. And for WebSockets, it's simple. So it's $1 per billion messages, approximately. They do have a kind of blended usage profile as well, but it's not very off from $1. And then it costs 25 cents per million connection minutes. And so this is how pricing is set up for API Gateway. One last thing I wanted to tell you before I let you go is about limits. These are kind of gotchas that have screwed me in the past, and I figure you should probably know about before you move on and start using this thing. The first is that there is a hard limit. It's a 30-second integration timeout limit. And you can't have your API Gateway go beyond 30 seconds when you're integrating with AWS services. It will simply time out, and you cannot increase this limit. It is a hard limit. So something to keep in mind, if you have long-running operations that are beyond 30 seconds, you're going to have to find a different way to do it. It's not going to work through API Gateway. The next one is in terms of payload size. So you do have access to a 10 megabyte max payload size. That is also a hard limit. You want to go over this, you probably want to use S3, kind of deliver the data to S3, give the user a pre-signed URL or something like that. But you're going to have to work around these two limits if you're using API Gateway in production. And so I do have tutorial videos that walk you through how to set up HTTP, REST, and WebSocket endpoints. So if you want to watch those, I'll put links right here. And thanks so much for watching. And don't forget to like and subscribe. I'll see you in the next video.